I need to train this system every day. How much am I going to be training it? Like that is what we're doing as distance runners.
Hey, I'm going to have a B race. My goal is to do a half marathon, so I'm going to do a 10K. And I'm going to see how I feel on that 10K. I'm going to go back.
When I got to nationals, I ended up breaking my foot. And it was because of what was going on internally with my body. I was devastated.
Try to real hover. And we're gonna bring it back up. Up.
But you can also build a base of speed. So something that neuromuscular development does, which varies from wickets to strides, is it helps build that base of speed. So
let's go ahead and get started. So without further ado, we're looking at running, training, basic, physiology, and application. So at my most recent race, I had a 10K race. I don't know if anyone recognizes that runner. Her name is Emily Sisson. She's the American record holder in the marathon and half marathon. And it was kind of fun to start off the race. I looked back and she's kind of trailing me, and I was like, oh, like I'm pretty cool to have this like super fast girl trailing me. So I'm like, oh, like she's very much more knowledgeable than me. So then I'm like, who's someone I can like run behind? So I did the same thing. But it was a lot of fun to kind of run that first half of the race together, and then she kind of had better endurance and just kind of took off, beat me by about 40 seconds in that 10K. But it's been kind of fun to run and to see the different people within training. Again, some of the influences I've already mentioned, Messer, Jack Daniels. A lot of you probably know about the Daniels running formula. That one's a great book over here. There's been a lot of different versions, but for those that are familiar with the term VO2, that's a really important term that he created through his research. Steve Magnus is a really good influence. Just really knowledgeable guy. I would say like if there's a single book that I would recommend for coaches and runners, it's this one, The Science of Running, which he wrote. It's extremely good. I don't know how to sugarcoat that. It's just so good. It's very dense of just awesome things you can implement in your training and in your coaching. And then though he kind of is long before all of these guys, Arthur Liniard, the idea of just periodization and building up the training program to build towards a peak, the focus of building your aerobic capacity, I definitely think of him as an influence. I guess I have that thing now. Yeah. All right. So we want to think about, as animals in the world, the pronghorn antelope. This was a reference, I believe, in the Lure of Running. It was also presented to me in my exercise physiology class with Dr. Messer. But the pronghorn antelope, this animal has a VO2 max of 300. For those that are familiar with VO2 max, that's a lot. So 300, to run a 5K in roughly 5 minutes, which is, a minute and 40 seconds per mile. So this is just slower than the cheetah, but can maintain that endurance for a long time. And so when we're thinking about becoming an efficient runner, kind of within the animal kingdom, like we need to be thinking about the pronghorn antelope. And that's the type of thing we need to be. We need to be kind of long, slender, utilizing these tendons. We need to have a large, powerful thorax with a strong heart, pulmonary system. Those are all really important attributes we need to kind of mirror. Today in the presentation, I'm going to be talking about how we need to build ourselves as race cars. So there's a lot of different attributes elite runners have physiologically that beginner runners or sedentary individuals do not have. And so I think if we can view it from the end in mind of like, okay, well, what would I look like, or what metrics would I carry with me with my running and my performing 3 or 4 years from now. If you have that mental picture, we can have a lot better training than not really having an idea of what we're trying to build. Oh, and also there are a lot of slides. We're not going to go through all the slides. I have a little red box around the ones we will cover. Just within a 45-minute time. We don't have time to do all of them. But the first one we're going to talk about is VO2 max. So in 1920s, we kind of learned about this. So we learned that as an individual starts running, the oxygen demands increase. And as you run faster, those oxygen demands go higher and higher up until a point. And then there will be a point where you can still run faster, but your oxygen is no longer able to keep up, right? And then at that point, you have to go anaerobic and you start to fatigue out. So that level that you can maintain is called your VO2 max. If I was in a lab, I would progressively, and I've actually measured my VO2 max, and so I've progressively, whenever I went through that process, gone up to faster and faster speeds, and then they just measure, you have a mask on, identifying the gases and the exchanges that way, up until you can no longer bring in more oxygen, and so that's capped out, but then you continue to increase your speed. That's your VO2 max. So we mentioned the pronghorn antelope is at 300. Elite individuals, depending on if you're male or female, are roughly like 70 to 80, 85. So that's significant. Compared to a sedentary individual or someone that's not really trained, we're thinking of like the 30s, maybe 35. So over double cardiopulmonary strength and that VO2 max ability. It's not nothing. It's a big change. Another thing that's important, didn't even do the slide. Another thing that's important is the ability to just bring in air from the outside environment. So we bring in that oxygen and it goes to our cells through our red blood cell, or to our muscle cells through our red blood cells and that pulmonary whole network. So that is much higher in elite individuals, that maximum voluntary ventilation. All right. Within VO2 max, the most important characteristic or thing you can measure is stroke volume. So when we look at VO2 max, there's a whole equation. It's called the Fick equation. It looks at your stroke volume times your heart rate times your AV difference, basically how much oxygen you can go to your cells and then how much CO2 you can get back up through your pulmonary system and breathe out. But that stroke volume is the most important factor there. When we think about elite individuals, their stroke volume is much higher than individuals that are sedentary or beginner runners, over double, right? So every time that my heart beats, if I'm an elite runner, I can have twice as much blood. So you can just imagine the efficiency that comes along with that. We can informally assess this by looking at someone's resting heart rate. That's kind of an informal way of checking this. So whenever you develop your VO2 max and your left ventricle size and power, your resting heart rate will be significantly lower, right? So instead of an average individual who might be 60 to 100 beats per minute, it's not uncommon to be a resting heart rate in the mid-30s. Mine's around 37 or so, just with aerobic training. And so that's one of the characteristics of an elite distance runner. Again, there's many principles I won't be talking about today, but they're important. You have to have good running economy. We have to be able to shift gears metabolically. So it kind of goes into a little bit of the lactate, which we actually will talk about this later on. Especially in the Arizona climate, we have to get used to running in the heat. For individuals that haven't been in Arizona summer, you'll learn that you need to do that. And then I'm doing like little cliff notes for each of these that we're not actually covering in depth. So muscle trauma for individuals that are elite. Big thing here is you're going to have increased satellite cells. So your ability to kind of break down and then repair much quicker is going to be higher in elite individuals. I mean, you're going to have increased amino acid uptake, so you can inhibit your increased protein synthesis compared to same age or sedentary peers. All right, one we're actually going to talk about. Shock absorbers. So I'm trying to make analogy for different car parts. That one doesn't really fit that well. There's not really a good one with tires, but all right. So what we're thinking about here is I want to think about those elastic properties. So whenever we think about running, there is active mechanics and passive mechanics. So we have to use active mechanics to fire our muscles to generate force to run. But it's identified that individuals that are elite can utilize passive mechanics much higher than other individuals. So specifically what we're thinking about with passive mechanics is we're thinking about the Achilles and then also the arch of the foot, so the plantar fascia. So if we can utilize that in an efficient manner, you're going to be significantly more successful with running. So that's kind of an analogy that I brought up here. And you can identify the ability to store and return that energy is much higher in elite individuals. Now, big picture, what are we trying to do here? It's similar to what we do whenever we train with plyometrics. We want to decrease our ground contact time. So whenever we're thinking about using these elastic, Achilles and the plantar fascia, we have to be able to actually be synchronized with our running, and it has to be like in a coordinated manner. So if we try to run very kind of slow, it's kind of harder to utilize the passive energy return. Now if we can change up our mechanics, and specifically the thing I like to target is that cadence. If we can have a higher cadence, it's much easier to use that passive energy. So as an example, individuals that are sedentary or beginner runners by default have a very much lower cadence. And so individuals that are elite, whether they learned or they trained it, we don't know, but we know that elite individuals have a higher cadence. And so personally as a coach, when I'm looking at a high school student athlete and I'm trying to help them with form, the first thing that I do is I watch their cadence, and it can't just be at the start line because everyone runs fast at the start. It's going to be mid-race, 3/4 of the way through a race, and I'm looking to see, are they able to maintain a high cadence level? And if the answer is no, then that's the first thing that I work on as a distance runner type coach. And because that's super critical. If someone is unable to have a high turnover, they can't really utilize their passive mechanics nearly as efficient as someone that does have a sustained high cadence. All right, we're going to talk about energy systems or energy pathways. So whenever we're thinking about max speed, we're going to be looking at our first energy pathway, which is that ATP. So all of it is ATP, adenosine triphosphate. So we're utilizing this energy throughout our body. Whenever we're thinking about sprinting as fast as we possibly can, we have these stores within our muscle cells. And then as we have longer distances, such as a 400-meter length, then we're going to be primarily focusing on a second pathway, which is glycolysis. And then as we kind of move up into anything over about 2 minutes, it's all that oxidative phosphorylation, so that aerobic metabolism. And I'll talk about each of them right now. So when we think about phosphocreatine, we're thinking about the stores that are within our cells right away. So they're there to be used, and we use them. Elite individuals, interesting thing is they can store more of them. In addition to storing more, they can regenerate quicker. So if we're doing workouts such as interval workouts, it takes about half, maybe even less than half the time as a sedentary individual to restore the phosphate creatine stores. That's significant when you're trying to get in interval work. When we're thinking about glycolysis, this is the second energy pathway. It's crucial that we have this established for individuals, especially in the kind of the mid distances. You have to have this for max speed. And the reason why I say that is compared to oxidative phosphorylation, glycolysis is roughly 100 times at a faster rate of inducing the energy. Now, the struggle with glycolysis is there's increased metabolites and waste products associated with this pathway. And so that's not good. Some of those metabolites, as an example, is hydrogen ion. And so that literally will go between that myosin and actin within your myofibrils, and it will impair your ability to use your muscles, which obviously is the exact opposite of what we want if we want to run fast. So one of the things that's kind of a saving grace for us as human beings is we have a different protein that's called monocarboxylate transporters. And there's 5 different types of monocarboxylate transporters in our body. What we're worried about as runners is MCT1 and MCT4. So MCT1 is the ability to bring lactate into the muscle cell. So lactate is an energy source, and we can use it as an energy source. MCT4 can help, it's a protein on the outside of the cell that helps remove lactate and metabolites away from the muscle cell. So that's really, really important. So if we're thinking about going fast and sprinting and going kind of all out, we have to use glycolysis. There's no option. Like, you know, there's other pathway like that one has the rate so much higher than the other ones, but we have to train it. An interesting thing about this is elite runners, they have increased glycolytic enzymes. So when we're talking about enzyme activity, these are things that speed up the rate at which these things are happening. So if you're working on sprinting, you're going to have increased fructokinase and then lactate dehydrogenase. So those are going to be significantly higher, which when you're thinking, oh man, that's going to have a lot more waste products, well, that's why we have those MCTs. All right, oxidative phosphorylation. If you're a distance runner, you have to train aerobically. As we saw in the chart earlier, anything over 2 minutes, the primary energy source is going to be through aerobic metabolism and oxidative phosphorylation. This is your biggest bang for your buck as a distance runner. There is no maybe should I train this energy system. It's I need to train this system every day. How much am I going to be training it? Like that is what we're doing as distance runners. And we're thinking about how much this contributes to a 5K. This is 90% of the energy is coming through this pathway. And the reason why is because this is extremely much more efficient. So whenever we're thinking about glycolysis, we're thinking one molecule, or one unit of glucose represents 2 units of ATP. With oxidative phosphorylation, for that same 1 unit of glucose, we're getting 30 to 32 units of ATP. So much more energy, way more efficient. However, it kind of takes a little bit longer. We have to go through the Krebs cycle. We have to go through this electronic transport chain. So that stuff takes time. Whenever I want to sprint, I don't have time, right? But with distance running at the kind of lower rate, we can utilize this pathway, and we need to utilize this pathway. And as we train, those enzyme activity increases, so we can utilize this pathway earlier. Whenever we, for example, start a race, all of these pathways start at the same time. It's just what are we getting the contribution from at any given point in time. So as you can see, those are a few of the more popular oxidative enzymes that we utilize, comparing the glycolytic versus oxidative. All right. Hey Nathan, I'm going to ask you a favor, maybe Eric too. Can you guys give me a 5-minute warning? So it's at, you guys can calculate what that would be. We started at
you do the math.
8, what did we start at? Roughly 8:20. So it's a 45-minute thing. You guys can figure that out. Just yell at me. Okay. All right. So the next thing that we're going to talk about is comparing ourselves to a car. So whenever we have something critically wrong with our car, there's going to be a way for it to tell us, hey, you got to slow down. You got to stop. There's going to be things flashing at us. And that's what we're going to get into next. This is a really interesting and fun thing we need to consider as distance runners. So the first thing is the central governor model. So what this model is suggesting is whenever we go out to run, whether that's a training run or a race, we're going to have subconscious kind of afferent signals being sent to our brain to give us a lot of information about how our body is feeling while we are running. And this is, again, subconscious. We're not thinking about it, but your brain is going to interpret all those signals, and it's going to cause you to pace and kind of slow down. It's hey, you're not running a 100-meter dash, you're running a 10K. What are you doing? And so it'll force you to slow down. And so this is a really important model to consider. So Tim Noakes, the author of that Lore of Running book that I really like, is the one that presented this. One of the things I'm going to present 2 different models. one of the things that I do like about the next model I'll present is that there is a little bit more consideration for motivation and kind of more of a cognitive factor. This, again, is like kind of more subconscious, and it's just kind of essentially saving us from killing ourselves. That's what this model is suggesting, is that it'll allow you to push it to the limit, but it's never going to let you go beyond that limit, that you would actually cause a critical threat to your own body. So that's what this model is suggesting. The idea with this model, though, is as you're a more experienced runner or elite runner, you're able to like kind of tap into a closer to your limits. And as you tap in more and more, your body can get accustomed to it and gets that feedback of like, hey, I've like ran this type of pace before. I'm okay, I'm not gonna die. And so then your body kind of eases up the reins and lets you go and continue to push it. So within like a training season or multiple years, you're able to kind of ease up that central governor that's slowing you down. So that's one of the models. The next model I really like is kind of more recent, the psychophysiological model. This one is talking about that there is cognitive considerations here. There's a lot of different research. Let me actually just go to this next page. There's a lot of research that he kind of presented where individuals were taken, they did a study, and they were asked to do 90 minutes of a demanding cognitive task, and then afterwards do a test for exhaustion, like until they're completely exhausted. And what they found was the individuals that had a very taxing cognitive demand for an hour and a half, as opposed to the other group that kind of just watched TV, I think that's what they said, there was significant changes related to time to exhaustion. So that, and there's a lot of implications there, potentially on race day or going into a hard practice, maybe after a testing day for student athletes, something to consider. Another thing that he mentions with this model is the idea that self-talk can actually help with performance. So if we're out there, having that self-talk is beneficial. In both of these models, they talk about afferent feedback and how it is important. One of the studies that he identified was they took two different groups of individuals. They did anesthesia just to affect the sensory fibers of the lower extremity, and then a control group didn't have that done to them. And what they found, and they asked them to cycle till exhaustion. And what they found was the individuals that had that anesthesia, they had an increased rate of perceived exertion compared to the other group. So even though they would do kind of the same expected workload, that rate of perceived exertion was much higher. And that's essentially what his theory, what he describes is whenever we go into a race, for example, the rate of perceived exertion is very low, and then keeping the exact same consistent effort throughout a race, that rate of perceived exertion will go up. So understanding that model and expecting, hey, it's going to get a little bit harder throughout my race, and I'm okay with that. Having that cognitive mindset is a very powerful thing. An interesting note with that is caffeine. I don't know if you guys are familiar with caffeine. Is very helpful for distance runners and performance. It actually, the way that it works is it decreases the rate of perceived exertion. So it's interesting that it kind of goes along with this theory. I keep forgetting I have this thing. Here's a comparison between the two. What I wanted to kind of draw your attention to, and what I would recommend as a takeaway, is when I go on race day, I like to think of the central governor model. That's just how I was trained, and I just feel like, okay, my fitness is where it is, and I'm going to perform at whatever level I'm ready to perform at. And I like to utilize the other model more for my training, personally. So whenever I think about, there's this idea of this cost-benefit analysis. So, I mean, we could think about it within a race as like, hey, this is going to hurt a lot if I keep this pace. Is it worth it? And if some people are like mentally a little like weaker, they're like, yeah, it's not worth it. And like, I'm pulling out. But for individuals that are kind of willing to dig deep, that's something. But I like to think of that with training, right? So is it worth it to run, 10 miles today? Yeah, that's not that bad. Okay, can we do that for a week? Yeah, I think so. How about a year? And so the expectations get higher and higher. And so I like to utilize this model as a mindset of, hey, if we're willing to go to like new levels, we need to be able to put in the work. And I do also want to tie in the reward factor here. So I'll give a personal example. And I did this before even knowing about this specific model. So a few years ago, I had been in kind of like the worst shape physically I'd ever been in my life. I went through high school and college, was really into running, and then took a break for about 8 years. Was at like the highest, weight on the scale, and then like fitness level was really low. I had like some cardio issues, and there was a lot of things that was just like, man, like I remember looking at my college running days, like, oh, that was the day, that was awesome, and just it was like, oh, but I'll never get back there. But I started like, okay, well, I'm gonna do it 1 hour a day. I'll just set aside 1 hour a day of running, and then we'll just see how it goes. And then as those kind of like, okay, week in, week out, those endorphins flow in the middle of that run. You guys have probably all felt that. Maybe like 5 miles in, you're like, oh man, like I can like take on the world, right? So then I thought, man, what I really need is motivation. Because when I was in high school, it was like, can I be the fastest in my school? Like, I don't know, I think so. Like, let's go find out. And then at college, can I get a full scholarship? Like, I think so. Like, let's go find out. Whenever like I'm a like 35, 36-year-old guy, like, what motivation like do I have? Like I was kind of like limited there. So I came up to my wife and I said, hey, like I have this crazy goal. Like I don't even know if I can do it. I literally at the time was like, I probably can't. But what if I were to give myself a reward and like force myself to kind of think that way? And so like she signed off on it. Like don't have a ton of money. I work for a school district, right? So the reward was, okay, if I can get a PR, then what I'll do is I'll get myself, at the time, the Xbox Series X was like a big thing. So like I'm gonna give myself an Xbox Series X if I can get a PR. Anything from like a mile, 5K, 10K, half marathon, like doesn't matter, like if I get a PR. And then if I could get 2 PRs, I'm gonna give myself like a huge 85-inch TV to go along with that Xbox, and I'm gonna like have fun with that, right? And I have kids, and we're gonna have a blast. So she signed off on that, and I was like, all right, let's get to work. It took me about 1.5 years. But it was, that motivation is what I needed to get out of bed, because that's always the hardest part as runners, right? Just like, okay, yeah, I'm gonna run tomorrow, and you wake up at like 5 a.m. You're like, oh, I don't want to go. Like, no, like, so I got out of bed and I kept thinking about all these different rewards. And then even within the race, and like, I remember when I broke it in the 10K, I was halfway through and I was like, oh, I gotta go. So forcing yourself with like personal like motivation is a great idea, and it goes right along with this model.
I think it was during that time is when you came out to that turkey trot and completely demolished us, and we always thought we were going to do really well, and then you came out there. Who's this guy?
Yeah, I kind of showed up, and I just got faster each year, and that was another part whenever I started joining in with Shadow, because I was like, how am I going to be able to run fast reps? I need access to a track. I need access to a group. And so the young high schoolers, for an older guy, like, is outstanding for getting that speed. Like, it was awesome. I was just like smiling, and they were just blowing me away with like 200s and 400 repeats. But then whenever it come to like 1Ks and like mile repeats, it was like, I've been here before, guys, let's go. And so that was kind of fun. All right, it's important, like there's a lot of advances in shoe technology for those that haven't been around. It's interesting stuff. We're not going to cover it today, but super shoes are legit, like they do help. All right, fine control of movement. So when we think about elite runners, they will have much more refined movement patterns. So when we think about co-contraction, right? We don't really want a lot of co-contraction. We want specific muscles firing at specific times within the gait cycle. There's a study here that talks about elite triathletes, equally trained runners, and then lesser trained runners. And what they found was lesser trained runners use those muscles longer throughout the gait cycle. And so obviously that use of active mechanics rather than the passive mechanics is going to lead to increased fatigue and less performance. So we need to make sure that we're neuromuscularly sound with our form. A way we can do that is through plyometrics. This is the Saunders study mentioned with highly trained runners. You can approximately get 3-fold improvement as compared to a control group not doing plyometrics. So there's a lot to gain through plyometrics. For those that aren't familiar, whenever we run, carbohydrates and specifically glucose is what we use in our body for running. That's stored as in a thing called glycogen, and that's within our muscle cells, as well as in the liver, which helps support the blood glucose levels. Elite runners have significantly higher amounts of glycogen throughout their body as compared to sedentary or beginner runners, as you can tell here. If you don't have the glycogen, then potentially you have to start utilizing fat as an energy source, which you can, but it's much slower and much less efficient. The chassis, so whenever we're thinking about building up like a body that can take on training, it's important to think about that. Specifically what I want to point your attention to is this right here. Why are we doing our slow and steady runs all the time? Like, we're always out there running, but whenever I race so fast. Like, what is the purpose of kind of these slower runs? And this is what I want student athletes, especially you guys in the back, the high school student athletes, this is why you're out here grinding away every day, right? You're building up the infrastructure of your aerobic machine, which is your body. And I'm going to draw attention to two specific things. Your mitochondria. When we talk about oxidative phosphorylation and all those oxidative enzymes, they're all within the mitochondria, right? That is how we are getting the efficient ATP. So we have to do this. Individuals that are elite have 2 to 3 times the amount of mitochondria, and they're also 25 to 30% more efficient. So they train and build up their body to have much more mitochondria and more efficient mitochondria. When I was at the Boulder Running Clinic, that's been a new focus, is having not only the quantity of mitochondria, but the quality of mitochondria. And there's been suggestions that a little bit of sprinting training, like Dr. Messer does 150 meter sprint strides, to help with the quality of the mitochondria. Vascularization. So in addition to the mitochondria, we have to think about building the ability to bring in the oxygen, get it to the muscles, and then get rid of all those waste products. And so to do that in our body, the vascularization is the key. So as we're running and we're having those hours of runs, we're building up the number of our blood vessels. So we think about the arteries, the arterioles, we have the actual capillary, then we have, going back to our heart, we have the venules and veins that go there. You have to build up that network. It doesn't happen overnight. It has to be a consistent thing as a runner. But individuals that are elite have roughly 2 to 3 times the density, and they have 20 to 50% the actual length. If you're taking all the different blood vessels and compare it to a sedentary individual, significantly more essentially highways to get back to that cardiopulmonary system. Nathan, what were we at with time? Let's see, 8:40.
You got about
10
10 minutes.
minutes, okay.
Before your 5-minute break.
All right, so consistency. If I haven't mentioned it already, consistency is critical as a distance runner. You have to go and just be consistent. I like to think, and I don't know because I've never actually had the experiment. I have 3 kids, and I'm hoping that they go into distance running and I can kind of experiment them as a dad, but I don't want to be that helicopter dad. But my thought was, if I can get anyone to be consistent, I can get them to college through distance running. But some of the things here, Jack Daniels, again, outstanding individual, he had a presentation at L84. All of this is going to be the same. Consistency is the key to success. Magnus saying the boring stuff is your foundation. And one thing I like about Magnus is he identifies not only the aerobic foundation, but also the speed foundation. In modern terms, we're kind of talking about max aerobic speed, max anaerobic speed. Those are the things we want to think about. Jeff Messer, challenging yet attainable and therefore sustainable. These are all just talking about how important it is to be consistent. And all of you guys know how important it is to be consistent. We just have to drill that into our student athletes, that they have to know that it's important to be consistent. This is from Jack Daniels' book. The idea is we have to induce a training stress, and it needs to be progressive. We need to continue to put stress on our body, but we can't overdo it, because as we have more mileage, we have increased chance of setbacks, right? So we have to be able to find that sweet spot, and each individual athlete is going to have a different sweet spot. There's a good book, Doug Souls. Anyone has read it, it's really good. I would recommend it. But mileage is really important. He's the coach at Harriman up in Utah, and they have a lot of mileage. So in general, if you can do it and you can tolerate it without injuries, try to do that. Individualized progression. So we need to take into consideration who we're working with. So if we have a good 400, 800 runner, versus a good 3,200 meter runner. You know, we like to think that potentially their muscle fibers are a little different. So type 1 fibers are going to be more of that endurance. Type 2, and there's various types of type 2, but type 2 is going to be more of that explosive, so they might be better at that 400, 800. I remember we were at Chandler and we saw, we had a really good 100 meter runner named Kai, and she went like internationally. I think she was in the top 5 in the world at the time. And the coach had her do an 800 meter, and we're thinking, oh yeah, like she'll be great with that. And she started off okay, but it's clear that muscle fiber type makes a big difference because the endurance just wasn't there. She went on to run at USC and did great and stuff, but it's just important to realize that each individual runner and their like characteristics of their muscle fiber type does make a difference. So you can't train everyone the same way. So consider that instead of having them fit into your program as a coach, how can you individualize? Have that as a focus as a coach. All right, this is very, very critical. So if there's like, I mean, I feel like there's a lot of, if you could just take this away, but if you could just take this away, this would really help you. So if you're a distance running coach or just running yourself, when you think about elite runners, they're going to be training roughly 80% of their runs are going to be easy or steady, very low heart rate, just kind of just putting in the hours, grinding out miles, right? The intervals and like the hard work is really what makes all the difference, or at least makes more of a difference, but it's very limited, right? So it's roughly 15 to 20% is of your workload. So in order to do that, what I would suggest as a coach is you want to make sure you get in consistent mileage, but you can increase like the warm up, you can increase the cool down. You have to have some of that slower work to have a good balance. When you're not balanced with your training program, kids are going to suffer. Increasing your anaerobic work at an excessive amount of, in compared to your aerobic work, is not good for most distance runners. All right. There's a lot of great stuff. I just don't have time. Like when we think about the energy pathways, this is presented from Dr. Messer about how like world record performances, and it's very clear that these are realistic. All right. Okay. We have like roughly 5 minutes. Perfect. All right. We're going to talk about this. I reached out to this researcher, and just to clarify a few things, and he was gracious enough to respond, and he sent me more research, and I'm very excited to look into more of that. But we're looking at 4 different interventions. So we took 4 groups, had them do long, slow distance, had them do a little bit higher intensity. So this would be kind of like lactate threshold, which is kind of hard to define, but we'll just say it's a lactate threshold group. Then they had a group that ran 15 seconds at 90 to 95% heart rate max, and then they had 15 seconds of active recovery, and did that 47 times in a row. Just kind of a difficult workout, I would think, as a coach administering. And then the last one was 4 minutes at that same rate, 90 to 95% heart rate max, 3 minutes active recovery, and did that 4 times. Here are the heart rate responses to exercise, as you can kind of see here. Yeah, and then we're going to go ahead and look at the results. So the study was about aerobic power training. So how can we help build the aerobic power? And what we found in this study was to build up, stroke volume and also VO2 max. These intervals, especially the 4 minutes on, was the way to go. So they kind of had a little bit, like pretty good results with that 15 seconds on, 15 seconds off. But the researchers suggested sticking with the 4 minutes because it's much more easy to utilize in a workout with individuals. So that's the way to work out your VO2 max and to build that interval up. So really hard, active recovery, jogging, really hard again, and then just do a bunch of those intervals where you're at basically your velocity of VO2 max. All right, so there's 3 kind of main things that we look at as runners. They're called determinants of running success. The second one we're going to talk about is running economy, and I know we're short on time, but just because you have a high VO2 max doesn't mean that you're going to always be the best runner. So this is Steve Prefontaine's VO2 max, about 84, and we think about Frank Shorter, who had a 71, so a much less, aerobically robust VO2 max. But due to his increased running economy, which is the second factor, they had really similar 10K times. And so from this study, what they found was all the groups actually increased running economy, but lactate threshold group increased it the most. And then the last thing that we're going to look at is that lactate threshold. So for those of you that aren't familiar with it, basically our goal with training is that we can increase the running speed at which we have that lactate start to accumulate. Again, lactate isn't a bad thing. It's an energy source, but it's more of an indication that we're starting to fatigue out. You can see easy, steady, tempo, and interval. And so we want to be pushing that. And what we found in this study was it was a mixture of the lactate threshold group and then the 15-second group. And that's the reason I reached out to the researcher of this study. I was expecting, like, hey, I was thinking that there would be increased amount of improvement with the lactate threshold group, because that's always what I've been told is to improve your lactate threshold, you train at your lactate threshold. But he actually suggested, I was actually expecting it to be more of these groups, because I was going to be required, or the individuals that using the study would have to recruit more fibers and go at a higher rate, which we know with the glycolysis, the higher rate is associated with speed. So that's what they were kind of expecting. So it was an interesting finding, but there's more to come related to all this. But that's basically my presentation is utilizing different workouts can provide different stimulus. And so we need to have a variety because as a distance runner, you have to have all the different tools in your toolkit. And I know I'm going to probably be out of time now, so I'll just kind of close. And I have my resources up here. So thank you guys for your time. I appreciate it. And we'll have a 10-minute little break, and then we'll get started with Eric's that is going to be talking about goals and things like that.
Can you answer questions during that 10 minutes?
Yeah. If anyone has any questions, feel free.
I have a question.
Yeah, Kels.
Talk about cadence.
Yeah.
Could you explain what cadence was or how you utilize that? So would you explain that for everybody?
Sure. So cadence is the amount of steps per minute when you're running. So how you could improve it, that's also why you're asking, or?
Yeah, you said you work with that on the cadence. What do you mean by that?
Yeah, so whenever as a physical therapist myself, I always think about the motor learning theory. And so with motor learning theory, there's three areas. So this is kind of a long-winded answer, but so basically we have the cognitive stage, we have the associative stage, and then we have the autonomous stage.
Just go the beeper. Just tell them about the
Oh, okay, yeah, I will. But basically, what we have to do is train our runners to be able to run without thinking about it. Because if we have to think about stuff, it's hard. And as we learned in the second model, cognitively taxing ourselves can actually decrease our performance. So if we can get to the point where we don't have to think about the motor aspects, that's a good thing. So there's ways of helping with improving cadence. We use beepers, little metronomes that you would put on like the belts or things like that. More recently, I've been a big fan of these Coros watches. I don't know if you guys are familiar with Coros, but they have metronomes built in, which is amazing. You can either have the feel, the pulse, or just have the audible beep, and you can change the cadence on that. But yeah, it's going to be the steps per minute is the cadence, and it's really important to build that up because here's the thing: if you have a student athlete that's running a race, whenever they're trying to speed up at the end of a race, there's two different options. They can either, let's say they're a lower cadence runner, they can change and then be, let's go from 150 or 160 up to 180, 190, and that would significantly change their running form. Or you can take someone that already is at a high cadence, we'll say 180, 190, and all they have to do is elongate their stride just a little bit, and that increase in stride length can help make them run faster. It's going to be much easier to run faster with that ingrained cadence. Yeah.
But doesn't having a shorter stride length be able to increase your speed too, to get up to the cadence at 180?
Does a shorter stride length increase your speed?
Right, so if you have a shorter stride length, let's say that you're running a stride of roughly about 1 to 2 meters, which is roughly about, if you're running something like 3 feet, your stride is 3 feet.
Mm-hmm.
That means you're going to run faster than if you have a longer stride, correct?
Right. Yeah, a big issue with especially high school athletes is they overstride. Right. Yeah, so what I'm trying to, I'm a huge advocate of having relatively choppy, shorter strides. Like I'm a big fan of that, just having that high turnover. What I'm saying is whenever there's the home stretch and there's 100 meters left to go and there's someone right next to you, you got to shift gears. How are you going to shift gears? Like you have to do, because we run faster only through elongating our stride or by increasing the cadence. Those are the only two options. So what I'm suggesting is if we can build the internally, the hard wiring of our body to have a higher cadence than everyone else, or at least like a lot of people, to a point, like it has to be relatively natural for you, but if we can have a higher cadence than the person we're racing against, it's easier for us to optimize both our stride rate and our stride, stride rate. So our cadence and our stride length. So that's how I approach it. Yeah.
What is a average cadence? Like, is it just depend on the person?
Yeah. If I take a freshman that's out running, never ran cross country, and we do 5-mile run, or we'll do the 3-mile run if it's a freshman, and they're not used to running. They might start, just anecdotally, they might start roughly, it's hard to tell, maybe 160 to start, and then halfway through a run, let's say we're doing that same distance, they're down to like 145. That's what I've seen. As individuals get used to it, they're able to recruit more fibers, then that can increase slowly. But yeah, it's pretty low, and it's kind of a challenge sometimes to motivate them to change that. Because I've been in workouts here at this campus with multiple athletes, and I get the feedback, oh no, like this is how it feels, like this feels best for me. And I'm not going to second guess that. I'm like, I believe you right now that it feels better to run at your preferred stride cadence. What I'm challenging you is, hey, like our goal is to get faster, right? Like our goal isn't just to be out here and feel good when we run. We want to get faster. Right, so we need to challenge our system, and so that sometimes is hard to swallow because kids, when they start increasing that cadence, it doesn't feel natural, and it feels harder to run at a given pace, which it is initially until that motor learning sets in, and then it can be more autonomic or to that autonomous stage of that motor learning.
Let me add to that. Most of that is going to come down to fatigue. Especially with newer athletes, their cadence is going to be a lot lower because they're not used to the running. So their cadence will be, their cadence will be a lot longer in stride length because of that fatigue factor. And then as they train, their cadence can increase, and therefore their stride length will shorten for that reason. And then obviously your stride length will actually get longer the faster you run. So.
Yeah, and just to follow up on that, so when you read Steve Magnus's information. What he found, and like the research suggests, whatever running technique or style related to like stride length and cadence individuals use as like a preferred manner, what they found in the research is at the like last sprint or to like speed up, they tend to switch it. So if I'm a runner that traditionally has a higher cadence, or we'll do the opposite. If I have a lower cadence to compensate and like to sprint in, then those types of runners are more prone to like literally change the, rather than having a kind of that higher turnover, they are more prone to having like more elongated strides. And it makes sense physiologically, right? So if we're using the same, and Eric, you can come up here whenever you're ready.
I'm just gonna, can I get a show of hands of who doesn't have a pencil? Sorry, I didn't mean to do that.
No, you're good.
Who doesn't have something to write with? Just 3. Okay, perfect. 4. Thanks, sorry.
And I actually didn't get your presentation. Did you put it up on?
Yeah, it's I shared it on the slides.
Okay, but yeah, just to finish that statement, it was an interesting note is whenever you're kind of fatigued and then wanting to like sprint in, there is a recognize that like people will change be the exact opposite kind of tendency, which is an interesting idea.